Hey folks, it's Shane from Performance EV. Today we're back working on our battery and charger. Hey folks, welcome to the channel. Thank you so much for joining us. So in our last video we managed to get the basically test that the charger was working and that it was taking power from the 230 odd volts AC and turning it into 300 and something odd volts DC and sending it through to the battery, and that seems to be working. Now what I want to do today is just take that setup a bit further and bring together all the components that will be working together on this when they're in the car, and just get them all wired up the way they would be in the car, so that when we go to actually install them, I know exactly what needs to be done, and I'm certain that it's going to work. So we've got our charger, which we know works. We've got our battery, which we do know has probably about 50% charge overall, and most of the cells are relatively well balanced. What I want to do is basically get them properly set up. So for the battery, it's going to be a case of getting all the wires together and getting them into the BMS. So that's this unit here. We'll look at in a bit more detail. Getting the wiring running through the high voltage junction box, because there are basically bits and pieces of the wiring loom come in here before they go out to the BMS and that sort of thing. And I don't want to, there's no point in disrupting too much of this. I might as well use what's there. So we'll try and get the main parts of the cabling and that wired up. And I also want to add another module between the charging cable, the charging port rather, on the car and the charger, just to control when the charger actually gets 12 volt power when it switches on, because I don't want to have it constantly on, because that'll be a big battery drain and that's just not worth it. So yeah, so we've got a few different things we need to get wired up here. Yeah, let's just get into it and I'll take you through all of them. Okay, so the first job is to get the battery sorted. So I've gotten and checked and made sure that the BMS is wired up correctly, so all of these sensor wires are going to the correct cells, or combinations of cells. And they do two things. They take readings of the voltage of each of the cells, but they also trigger the bypass circuits as part of the balancing. So it's important that they're wired up correctly, and if not, they can be known to blow up some of the stuff in the BMS module itself. But because this battery pack's not being used in its standard formation, some of the wires were too short for where I'm planning to have the BMS, some are too long. So I've basically cut and spliced the wires, so shortened some of the long ones and used those wires to splice in and lengthen some of the ones that were too short. And now I just want to basically get all this bundled up so it's nice and neat and secure and not going to get damaged, and we'll just tape everything up so that these aren't all floating all over the place. I had to take all the previous tape off as I was trying to figure out if I'd gotten the wiring correct for all the modules, so we need to do a bit of tidy up on that. Alright, let's look at the components we've got that make this all up. So, on the battery side, we've got the battery pack itself, 24 modules in series, for a nominal of about 360 volts. On one side of the battery pack, we've got the isolation connector. So that's bridging the two halves of the pack together, and it's currently disconnected. We've got this plug that goes in there, and that basically bridges the two and brings the pack up to full voltage. It's just basically a very beefy little bus bar that slides in a nice safe plastic package. By taking this out, there is then no connectivity between the other two ends, so the battery is essentially isolated. On the other side, you've got the two inlets, outlets, so positive and negative, coming off the battery pack, and they'll go, in this case, into the charger. That's also where connections will go to the high voltage junction box and out to the inverter. Speaking of the high voltage junction box, we've got the main component here. As some of you will remember, I did build my own high voltage connections for the testing using the small contactors from the CHAdeMO circuit in the power delivery module. This is much more substantial, so it's got the beefier actual drive contactors here, one for the positive and one for the negative circuit, and then we've also got our pre-charge contactor and our pre-charge resistor here, and all the necessary wiring and controls in there. The control wires for that come out to this plug here. Also connected to that plug is the BMS, so that's where it gets its 12 volt from, and it's any CAN messages coming in and out. So that'll plug into the BMS, also notifying it that this isolator is in place, and the rest of the detail coming in the BMS is coming from these now nice neat wires, which are taking the data from each individual cell on the pack, and also controlling the kind of balance circuits that are inside the cells, so that they can be for actually balancing the battery as a whole. So that's a job that the BMS takes on. So that is our battery setup. On the charger side, we've got our charger. We've got it wired up for control, as we went through in the previous video, and then we've got it wired up for power. The control wiring goes out through this port here, and we're using one of the screw holes to ground the whole operation. But you've essentially got 1, 2 or 3 modules available, and they will have the live from the AC going in there, and you've got the negative coming in for the negative, or for the neutral. And then you've got things like the nice beefy fuse in place there. So that is wired up, ready to go, connected to the battery. In terms of controlling the charger, we've got our control board, which I've now managed to get to fit inside this casing. It's open at the moment because I wanted to see the little blinky LEDs blinking, but we'll basically put this inside the case there and seal it with some silicone sealant to make sure it is waterproof. So you got wires coming into the, or out, I guess, both. One side is the control circuitry from the charger, the other side is going out to the car. If we look at what's going out to the car, we are coming to battery, which is also acting as our, I guess, our chassis ground. So it's got the negative going there, and then we've got our positive, which nothing is wired to at the moment. In terms of our positive, it's worth noting that we're not just going to be sending power into the control circuit, which would send power into the charger. We're actually making things a little bit more complex, and we've got a couple of additional components in play here. So why have we got additional components in play here? 2 reasons. One, I don't want power always going to this unit, because there'll be power always being drawn by the charger, and that will create a drain on the battery. The second is that the Tesla charger is quite delicate in some ways, in that it needs to get within 10 seconds of it getting powered on, it needs to get the signal coming from the charger. And so that means you need to control things to make sure that it's only getting power when the charger's plugged in, or just as it's being plugged in, and then everything works nicely. So what I've got in place is a SIMP charge, which is a little module that handles the communication with the charger, and that is going to be talking to both the charger wiring, or the charging port, and the charger itself, as well as controlling a relay. And we're going to be sending any power is going to go through a fuse box. The reason I've done that is I want to draw 12 volts through the relay out to the fuse box, and then distribute it out to not just the charger and the charger control circuitry, but also the cooling circuits in the car. So hit the relays that will switch on the fan, switch on the coolant that will flow through the charger, so that when the car is sitting there charging, the charger is actually being kept at its optimal operating temperature, rather than only giving me like 10 minutes charge before it fries. And then the other circuits we have in place are the charging port and the external charging cable there. So now we need to just make sure everything is wired up. So with any charging port, and it doesn't matter whether it's a type 1 or a type 2 charging port, in addition to your kind of live and neutral power connections and your grounds to the chassis, you've also got two communications. They're not complex communications, but they're communications nonetheless. One is called your proximity and one is called your pilot. You can never remember which one's which, because it depends on whether you're looking at the charger or the charge port as to which one's on the left, which one's on the right, but I'll put a diagram up to show. But basically your proximity lets the onboard charger, so our Tesla charger in this case, know that there is something plugged in, and then the pilot lets it know that things are all okay. So it's back and forth communication, just using voltages and square waves, letting the systems know everything's okay, and that it's fine to send through some charge, and then or send through electricity, and then the charger decides how much it's going to draw and what it's going to do with that. So we're going to actually send one of these signals to the charger and one to the SIMP charge. So we're going to send the proximity to the SIMP charge, so that it will provide power. So it will then signal the relay when it detects the proximity, and that will provide power to the onboard charger, letting it know that there is an actual charging cable plugged in. And then the control pilot will be sent to the charger itself, and that will then let it know how much charge to actually give. And by combining those two, we're ensuring that the charger is only switched on when it needs to be, and that the charger knows what to do when it receives it. So yeah, let's plug this all together and see where we go. So I've marked off the different wires. So then, now going back to the battery side of things, in terms of the wiring, we've gone through this in more detail in another video I did a while back on the battery, but I'll go through it again here. We've got our BMS here, and we've got the wires coming from the various different parts of the battery pack. I will be adding some orange tape to all of these so that anyone looking at it knows it's high voltage stuff. Then we've got our connections to the temperature sensors within the pack. There are 3 of them, I think, on this one. And then we've got our connections to other things. So these go out through the loom to a range of different things. Some of them go to the isolation switch here to make sure that it's closed, because the that allows the BMS to tell other systems not to do anything if this isn't actually properly closed off. We've also got connections to a current sensor, so we'll try and reuse that in the setup in the new car. And then the rest of them are looking a bit more externally and are coming up to this connection here along with the high voltage junction box. So then within the connection here we've got ground wires, we've got positives, so that's kind of constant 12 volt plus switched 12 volt. We've got our CAN communications, and then we've got our controls for the various contactors in the high voltage junction box. So in terms of testing the charge, which is the first thing we're going to be doing today, we're going to focus on these pieces and the CAN communication. Not going to be actually communicating with it, but I want to be able to read it with the Leaf Spy. For that I've got a Wi-Fi OBD2 dongle. Now didn't open this up just so it looked like everything else I'm working on. I actually was having a problem with it, and turns out one of the connections between the kind of logic side of it and the communications, the Wi-Fi side of it, had gotten caught when the case was closed in the factory, and eventually that had just screwed up the communications between the two, so I had to splice in a connector there. But yeah, it's working now, so it just needs power, a couple of grounds, and then it's got the CAN communications as well. Alright, so let's see if I can get all this hooked up single-handed, because I'm holding a camera. So first of all, we want our negatives on. So that's negative going to the BMS and anything else in the high voltage system. Then we've got our lives. So we've got our permanent 12 volt, and then our switched and power. So that should be powering up the BMS now. And I can hear it ticking. So that's a good sign. Now we want to get power to our OBD2 scanner. This one using crocodile clips. And then we want to hook up our CAN high and CAN low. So it's going from the BMS through to the system. Alright, I need two hands for this. Alright, so we've got that plugged in, it's firing away. We've got the BMS working. We switch that on, we can see we've got some action on the Leaf Spy, about 355 volts for the total pack. Okay, so we've got everything trucking away there, tracking the voltage and that. So let's see what happens when we bring it all together. So I'm going to record some screenshots, and then we'll go down and play with the charger. Okay, so we've got our plug-in charger plugged in. It's ready to go. We've got our Type 1 plug, and let's bring it around, plug it into the charge port and see what happens. Okay, so this is data being presented in Leaf Spy, which is a mobile app that connects to a Nissan Leaf via an OBD2 port, which is what I've got. But basically, we're just taking a small subset of the CAN data that this app is able to interpret, which is just the BMS data, and it's presenting it for us in this nice graphical format. And each kind of column here represents one of the cells in the battery. So not the 24 modules, but actually the 4 individual cells that make up each module. And yeah, it's just presenting them in a neat graphical format and allows us to see exactly what's happening. So at the moment you can see it's about 355 volts. We're going to plug in the charger and see what it shows. All right, so you can see here that the voltage is kind of just hanging out at around 355.3 volts, fluctuating up and down the overall reading. I think that's mainly just due to how it takes the calculations and the fact that it is actively opening and closing the shunts on the batteries to transfer a bit of power from the slightly higher charged ones to slightly lower charged ones, just as part of the balancing. So but 355.3 is kind of the voltage that it's sitting at the moment. And now, as we plug in the charger, you see that voltage starts to come up. It's not kind of ramping up really quickly because it's a really slow charger that I've got just a little home battery charger, but you can see that it is the voltages are increasing. Now if we look and focus on the headline voltage again, just looking at the same time frame, you'll see the point at which the charger is plugged in, suddenly the voltage starts to go up and keeps on going up. And then when we unplug it, the voltage drops back down from what it had been showing on the charger, but it drops back down to a higher level than it was before. So we've gained about 0.15 volts in the minute or so that we were charging there, which is great. So the final thing I wanted to do before, I guess, signing off that this all works and is ready to go into the car was just to check the high voltage junction box. So we've got our connections coming into this this connector. I don't know if I'll reuse this connector or if I'll just cut all the wires off and put it in something else, see what I can get my hands on. Basically there's 3 inputs there that correspond to the 3 wires here, and it should be that if I provide 12 volts to any one of these, that will then cause the corresponding contactor to fire, and it will close the circuit. So actually, why don't I put the microphone on the contactor I think it is going to fire, and we'll see if we can hear anything. So first off, we'll test our positive. Then our negative. And now our pre-charge. Pre-charge sounds weedy in comparison. But yeah, so that's pretty easy. So basically these wires will go in the same way as my original design had it. Those wires will go as an output from this software powered relay block, one for each, and this will receive as an input the signals from the inverter. When the car turns on, the inverter will initially turn on the pre-charge, so it'll send a signal that will fire that relay and the negative at the same time, and then the main positive relay will fire a few seconds later. So that should be nice and easy to wire up. All right, I'm pretty happy with the way that turned out. So we've successfully run a bunch of tests on the charger. It's working. The BMS with Leaf Spy is able to read what's going on inside the battery. It can see when the charge is coming through, which is awesome. All the wires and connections and stuff for the 3 contactors are spot on. They're working, so we can get those hooked up when we put this all into the car. And that's basically everything I can do until I put the battery into the until I build the battery box and put the battery into it. So basically the plan is that these boxes that I have on top of here will be kind of form part of the lid of the battery box. They'll have access holes down into them from which various connections to the battery can come through, be it the the wiring for the data for the BMS, or the high voltage cables coming into a kind of termination here that will then go out to the high voltage junction box, go out to the battery, through grommets that will keep it all watertight and secure. And yeah, it'll essentially fit along like that. Not the slickest looking things in the world, but they'll do the job. Might even spray them the same color as the car, just to give it a cleaner look. But yeah, we'll start getting to that over the next few weeks. We'll try and get the battery box built, get the battery into it, and just go from there, and then get that into the car. But yeah, things are really coming together now. And yeah, if you want to see more of this project and you're not already subscribed, please consider subscribing. Drop me a comment if you've got any thoughts, suggestions, anything you want to say. I do try and read all the comments. And yeah, thanks for joining us, and we'll see you next time.